So this time we have a bar that is constrained. Unlike the previous video, our bar was unconstrained, but this time we have a bar that is constrained. So what's the difference? Let's find out. Of course, we're going to have to calculate the thermal stress that is induced, and that is going to happen as a result of the bar being constrained between a chuck and a tailstock. So this is basically on one of those lathe machines. So let's get the idea of the question first of all. So it's a brass bar and it's 600 mil long, and it is held between the chuck and the jaws of a tailstock. So what we have that the bar is heated from 20 degrees Celsius to 95 degrees Celsius, and we need to calculate the thermal stress induced in the chuck. We have these values for our coefficient of thermal expansion, and we have our modulus of elasticity there. Modulus of elasticity there. So let's get into the calculation, and you should be fine with this one because I'm going to break it down step by step. So we actually have a formula that we can use to calculate thermal stress. And you're probably familiar with the formula that we used previously to calculate stress as it relates to force and area. But this one is actually for thermal stress, and it's quite straightforward. We're going to get into it now. But just before we do that, guys, please, I'm trying to grow this channel to reach as many people as possible, and it requires your support. So if you don't mind, I'd really appreciate if you subscribe to the channel and give the video a thumbs up just to show your appreciation. I will upload videos 5 times per week at least, and that's Monday to Friday. So let's get into the calculation. That's what you're here for. So stress here is equal to our modulus of elasticity times our coefficient of thermal expansion and times our change in temperature. Quite straightforward stuff. So what we have the modulus of elasticity, 90 gigapascal. So 90 times 10 to the power of 9. We have the coefficient of thermal expansion, so that's 20 times 10 to the power of negative 6. And our change in temperature is just the difference between the initial temperature and the final temperature. So that's 95 take 20, so that leaves us with 75. And if we multiply all of that, then that leaves us with our 135 times 10 to the power of 6 Pascal. And this is representing the thermal stress in the bar. So quite straightforward calculation. But the next one that I will analyze with you, it will be a little bit more challenging because we're going to add a spring to it. So let's see what will happen in that calculation because there will be a lot more factors involved. So check this video out next to find out.